Here are 20 quirky and intriguing facts about them. Neutron star density. A neutron star, which is a type of dwarf star, is incredibly dense. Just a sugar cube-sized amount of neutron star material would weigh about 100 million tons on Earth. Pulsars. As cosmic lighthouses, neutron stars can be pulsars, which emit beams of electromagnetic radiation. These beams sweep across space like lighthouse beams, creating a pulse of radiation every time they pass by Earth. White dwarf cooling. White dwarfs start off incredibly hot, but over billions of years, they cool down and fade away. They can eventually become black dwarfs, though the universe is not old enough for any black dwarfs to exist yet. Extreme gravity. On the surface of a neutron star, gravity is so strong that it warps spacetime. If you could stand on one, which you can't because the gravity would crush you, you'd weigh about 2 billion times more than you do on Earth. Magnetic fields. Neutron stars have some of the strongest magnetic fields in the universe, trillions of times stronger than Earth's magnetic field. These fields can twist and distort light and influence the behavior of nearby particles. White dwarf fusion. When white dwarfs are in a binary system and accumulate matter from a companion star, they can ignite fusion in a runaway process, leading to a Type Ia supernova explosion. Tiniest stars. White dwarfs are incredibly small compared to other stars. They are roughly the size of Earth but contain as much mass as the Sun. Neutron star speed. Some neutron stars rotate incredibly fast, up to 700 times per second, which is nearly the speed of light. This rapid rotation helps stabilize the star against gravitational collapse. Black dwarf future. Though they are theoretically predicted, black dwarfs are purely hypothetical because the universe isn't old enough for them to form. They represent the final stage of a white dwarf's life cycle. Different colors. White dwarfs are not always white. Their color depends on their temperature. They can be blue or even red if they're cooler. The Crab pulsar. The Crab nebula, the remnant of a supernova explosion observed in 1054 AD. Contains a neutron star. The Crab pulsar that spins about 30 times per second. Size of a city. The entire mass of a neutron star is packed into a sphere only about 10 to 20 kilometers across. Roughly the size of a city. Diamagnetic stars. White dwarfs have extremely high electron degeneracy pressure, which prevents further gravitational collapse. This is a form of quantum pressure that keeps them stable. Magnetars. A subclass of neutron stars called magnetars have magnetic fields up to 1,000 times stronger than regular neutron stars. Their magnetic fields are so intense they can cause starquakes. No atmosphere. White dwarfs don't have atmospheres like other stars. Instead, their surface is made up of a thin layer of highly compressed matter. Cosmic speed limit. Neutron stars are often ejected from their birthplaces at speeds of up to 2,000 kilometers per second due to the asymmetric explosion of the supernova that formed them. Pulsar planets. Some pulsars have been found to have planets orbiting them, which are often thought to be rocky and can survive the extreme conditions of a pulsar's environment. Oldest stars. Some white dwarfs are among the oldest stars we can observe, with ages that approach the age of the universe itself, around 13.8 billion years. Iron core remnants. The core of a white dwarf is mostly composed of carbon and oxygen, remnants of the fusion processes that occurred during its earlier life as a star. Star composition. When white dwarfs cool down sufficiently, their outer layers might crystallize into a solid form of carbon and oxygen, making them resemble giant cosmic diamonds.